Hey everyone, so this video is going to talk you through all of the properties of integrals that we're going to be dealing with. So the first one we're going to talk about is the order of integration. So if we take a look, we've got this integral from a to b of f of x dx, and it's telling us that it's some area s, so some number. So if we think about what that might look like, it could mean we've got this function maybe like this, and let's say here's a, that's where we're going to start integrating, to b. So if I want to find that area S, that really means I'm going to trap the area between A and B, the function, and the x-axis. So this orange area here is whatever this number S is. Since A is on the left and I'm moving towards B, and this is above the x-axis, this is a positive area. But take a look at the next part. The next part says, what if we switch those bounds? So now I'm going to start at B and I want to end at A. So now I'm moving the opposite direction. All that means then is now my area is negative. So anytime you switch your bounds of integration, all it does is make your area negative. For the next one, we're looking at the integral from a to a of f of x dx. Well, the thing that we have to remember, if we've got this function here, if I'm going to start at a and I'm going to end at a, it means that my rectangle is not going to have a base if I were going to use one of my sums, right? One of the RRAM, LRAM, midpoint. It would mean that this is a rectangle with no base, which means that this is going to end up being 0. And this is because we start at a and stop at a. So we start at x equals a and stop at x equals a. So that means there's no area accumulated, because we're not moving over to actually create a base at all. So anytime your bounds are the same number, you have 0 area accumulated. Alright, for this one, we've got the integral from a to b of f of x dx is that s, so this same picture that we had up here. Now we're saying that we're going to do the integral from a to b of some constant k times f of x dx. Well, the thing that we have to keep in mind on this one is that this f of x is really just the y values. And so what we're doing is we're doing the integral of k times these y values. Well, the nice thing about this then is this can actually be the same thing as taking that k and moving it out front. So now it's k times the integral from a to b of f of x dx. And we know that this integral right here is equal to this area S that we already found. And so this overall area then is just k times S. I'll show you guys a nice visual in class to help you understand that one, but it's a little bit harder to draw and understand. So I'll show you some stuff on Desmos to kind of help clarify that. For the next one, we've got the sum and difference rules. So if we're doing the integral from a to b of f of x plus or minus g of x dx, then we can actually just break up the integrals. So we can do the integral from a to b of f of x dx plus the integral from a to b of g of x dx. And same thing goes with the minus. I'm going to stick that plus or minus back in there. So if we're adding two functions together, we can just break it up into two separate integrals and have the bounds be the same, and we'll still get the same answer. For the addition rule down here, take a look at your bounds of integration. We're doing from a to b of f of x dx plus the integral from b to c of f of x dx. So you'll notice this integral stops at b and this one starts at b. Let's think about what this might look like. So if we've got some function here, and let's say this is a, this is b, and then this is c. So if I want to find the area between a and b underneath this function, that's going to be this orange area right here. And then if I find the area from b to c, that's going to be this blue area. And if we look, that's really the same as just starting at A and going all the way to C, which means if this end bound and this start bound are the same, and we've got the same function there, then we can really just do the integral from A to C of f of x dx. All right, this last one is very similar to the sum and difference one above it, but we have to be very careful on how we think about adding an actual constant here. So this k that we're adding is a constant. It's not its own separate function g of x. Well, it kind of is. But let's take a look. So I can break it up first, and I can say, okay, that means the integral from a to b of f of x dx plus the integral from a to b of k times dx. But we have to think about what this actually means. If k is a constant, then that means it's some type of horizontal function. So I'm going to say whatever this is. This is my y equals k. And we're integrating from a to b, which means whatever this constant k is, it actually adds this whole rectangle's worth of area to the function's area. So if we know the integral from a to b of f of x dx and we can find that, we're going to end up having to add a total rectangle to it, which means we can really write this as the integral from a to b of f of x dx, so whatever area we get there, plus, since this is a rectangle, we can actually find the area of the rectangle. It's base times height. The base is the distance from a to b, which really just means b minus a. And then the height of the rectangle is that constant k. So you want to make sure we're not just adding k, we're adding an entire rectangle that goes underneath it. I'll show you another one on Desmos tomorrow that'll help show you exactly where this comes from. All right, we're going to do just a couple of examples to make sure that you guys are good, and then I will let you go for the night. So use the rules of definite integrals and the following known integral values to answer the questions. So for question 1, we're looking for the integral from 4 to 1 of f of x dx. Well, if we look at the things that we were given the integral from 1 to 4 of f of x dx. We know that if we've got the same bounds of integration and they're just flipped, that's really just going to be the negative integral from 1 to 4 of f of x dx. So let's see, that's going to be a negative. The integral from 1 to 4 of f of x dx is negative 2. So negative negative becomes a positive. This area is a positive 2. And that's all you have to show me. That's all it is. Let's take a look here. We've got the integral from negative 1 to 4 of f of x dx. So if we look, these two pieces here are both f of x. So from negative 1 to 1 of f of x dx is 5, and from 1 to 4 of f of x dx is negative 2. We can see that this integral stops at 1 and this integral starts at 1, which means I can take this original integral and I can say that it's the same as the integral from negative 1 to 1 of f of x dx plus the integral from 1 to 4 of f of x dx. And now I can just plug in the values that I actually know. So let's see, negative 1 to 1 is 5, plus 1 to 4 is negative 2. So this area becomes 3. All right, number 3 looks a little bit more complicated, but it's really not. So for number 3, we can see we're doing integral from negative 1 to 1, and we've got 2 f of x plus 3 h of x dx. Well, we're adding these two functions together, which means we could really split them up. So I can write this as negative 1 to 1 of 2 f of x dx plus the integral from negative 1 to 1 of 3 h of x dx. Now hopefully the next thing that you see is that we've got these constants in the front being multiplied, we can actually take those out then. So this is going to be 2 times the integral from -1 to 1 of f of x dx plus 3 times the integral from -1 to 1 of h of x dx. And so let's see, we get 2 times the integral from -1 to 1 of f of x is 5 plus 3 times the integral from -1 to 1 of h of x is 7. So do we get 10 plus 21, so we get 31 as our total area there. You have to be familiar with how to break this up and how to write it, because some of the multiple choice questions on the AP exam are just going to give you these expanded versions. They're not going to actually get to numbers. So I do want you guys comfortable with writing this out and knowing how to break this down as much as you can. All right. For question number 4, you'll see that we're adding that constant there. So this is kind of like that last property that I just talked about on the last page. So the first thing we're going to do is break up our function, because I'm adding, I just dropped my pen, sorry guys. We're adding 2 functions together. So this is really the integral from 1 to 4 of f of x dx plus the integral from 1 to 7 1 to 4, I don't change my integration, 1 to 4 of 7 dx. So we know that this portion right here from 1 to 4 of f of x dx is really just -2, so that part's easy. But we need to figure out exactly what the integral from 1 to 4 of 7 dx looks like. So remember, if it's just the function y equals 7, that's just a horizontal line at y equals 7. And we're integrating from 1 to 4. So if I want that area there, that's just a rectangle. The distance from 1 to 4 is 3, and then the height would be 7, which means this area of this green rectangle here is going to be 21. So the total area here is -2 plus 21, so we get 19. And that's our final answer for that one. All right, I want you guys on your own for homework to try numbers 1, 2, and 4. I'm going to do number 3 with you really quickly right now, and then we're going to talk about this last thing at the bottom here. So take a look at number 3. Number 3 says we want the integral from 1 to 2 of -5 times f of x dx. Well, if we look at these integrals up here, we've got the integral from 0 to 2 of f of x dx, and we've got the integral from 0 to 1 of f of x dx. We're looking for the integral from 1 to 2. So we have to make sure we're careful about how we get this. So I think the first thing I would do here is take out that -5, because it's just a constant being multiplied in front. So this is the same as -5 times the integral from 1 to 2 of f of x dx. And then what I want to do is I'm going to go to the bottom really quick and write out a couple of things so that this is a little bit clearer. So we know that if we've got the integral from 0 to 2 of f of x dx, that's the same as the integral from 0 to 1 of f of x dx plus the integral from 1 to 2 of f of x dx. So this question 3 that we're trying to find, the thing that we don't know is this integral from 1 to 2 of f of x dx. But we do know the integral from 0 to 2, and we know the integral from 0 to 1. So we're going to have to use these pieces to be able to find this unknown part. Hopefully you guys can look at this and just see then if we subtract these two integrals, we would be left with the integral from 1 to 2. So I'm going to write that up here. So now we're going to have -5 times, and I'm going to go ahead and put a bracket here. We need to do the integral from 0 to 2 of f of x dx minus the integral from 0 to 1 of f of x dx. And I know you guys are probably annoyed that I'm going to make you write that, but the reason I'm going to make you write it is because if you don't, you guys lose track of negative signs and then things end up being incorrect. So take the time to actually write it out and figure out what it is you need. So now let's see, we've got negative 5 times the integral from 0 to 2 of f of x dx is 4, minus the integral from 0 to 1 of f of x dx, which is just 1. So in this case, we didn't have to worry too much about negative signs, but just trust me on it. So we get negative 5 times 3, we get an area of negative 15. All right, so again, I want you guys to do 1, 2, and 4 on your own. Bring them back to class with you, and when I check in your notes, I'm going to check and make sure that those are completed also. I almost forgot. We got to talk about this. So the one thing that you cannot do with integrals is you cannot break up integrals when you're multiplying. So the integral from 0 to 2 of f of x times g of x dx is not the same as the integral from 0 to 2 of f of x dx times the integral from 0 to 2 of g of x dx. You are not allowed to do that. You can break up ones when you're adding or subtracting. You can pop out constants, but you cannot take two functions, that are being multiplied and break them into two separate integrals. Don't ever, ever, ever do that. I promise it will show up on a multiple choice question and it will trick you if you are not careful. So please make sure that's written down. If you have any questions, make sure you wrote them down, and I will see you guys back in class.